electromagnetic radiation does a typical home router emit when the Wi-Fi is turned on? The normal background reading of electromagnetic radiation, rarely above 75 millivolts per meter or 0.075 volts per meter when Wi-Fi is off. I will set the meter so it picks up the maximum readings. It is normal for the meter to jump a few millivolts when moved or handled. The router Wi-Fi is enabled and transmit protocol selected is mixed. Mixed will transmit on two frequencies. The 2400 MHz or 2.4 GHz band and the 5000 MHz or 5 GHz band. This meter only picks up frequencies of 3.5 GHz or less. That is, the higher of the two router frequencies is not picked up by this meter. Watch for the change in numbers on the meter when the light in the red box comes on. Watch for the jump, and the light came on. The meter is now reading volts per meter, 9 volts per meter or 9,000 millivolts per meter. While the meter is searching for or attempting to connect to wireless systems, the unit spikes to almost 18 volts per meter. The normal background reading of electromagnetic radiation, rarely above 75 millivolts per meter or 0.075 volts per meter when Wi-Fi is off. The router Wi-Fi is enabled and transmit protocol selected is mixed. Mixed will transmit on two frequencies. The 2400 MHz or 2.4 GHz band and the 5000 MHz or 5 GHz band. This meter only picks up frequencies of 3.5 GHz or less. That is, the higher of the two router frequencies is not picked up by this meter. Watch for the change in numbers on the meter when the light in the red box comes on. The meter is now reading volts per meter, 9 volts per meter or 9,000 millivolts per meter. While the meter is searching for or attempting to connect to wireless systems, the unit spikes to almost 18 volts per meter. Closer look at the router specs, then how to measure electromagnetic radiation in the near field or very close to the source. The Cisco Lynksys wireless and broadband router user manual. The unit can operate using Ethernet or wired connections as well as on two radio frequencies, 2.4 GHz and 5 GHz. This unit cannot operate on the 0.9, 3.6 or 60 GHz bands as the protocols permit. The more frequencies, the more complex to impossible to model the near-field radiation pattern. The manual includes this warning. Most other routers and similar devices have similar warnings. This equipment complies with Industry Canada exposure limits set for an uncontrolled environment. This equipment should be installed and operated with a minimum distance of 20 centimeters from the radiator and your body. This transmitter must not be co-located or operating in conjunction with any other antenna or transmitter. If these units are safe, why is Cisco printing this warning in their manual? Many recognize the safety code 6 this warning is based on is far from adequate. The manual was written to safety code 6 2009. The limits for the frequencies this router operated on were appreciably reduced in the 2015 version. The reductions in the allowable limits are noted on this page. The 2.4 GHz band electric field was reduced from 61.4 volts per meter to 44.9 volts per meter, or if measured in power density terms, from 10 watts to 5.5 watts per square meter. The 5 GHz band electric field was reduced from 61.4 volts per meter to 57 volts per meter, or if measured in power density, from 10 watts to 8.83 watts per square meter. It is strongly recommended that one download the toolkit from the BC Centre for Disease Control. This tiny URL for the toolkit. Sections 2 to 5 inclusive are a good primer to radio frequency science. The head of the radiation section provided additional information when asked to clarify a point. He advised, never use a power density reading in the near field. Rather, one should measure the electric field and magnetic field separately in several locations. The location with the highest product of these values is the power density. If one is reduced to incomplete readings based on calculations assuming the far field constant supply, multiply the calculated power density by 4. This is the gist of the information contained in Technical Notes 329 and 261 from Industry Canada. Technical Note 261, especially the appendix, contains valuable information about the special considerations in the near, intermediate, and far fields. What do the readings mean in relation to understanding Health Canada, Industry Canada, or FCC guidelines? As the meter was reading only one of the two transmitting frequencies, assume one measure of both frequencies would need approximately 36 volts per meter. 45 volts per meter is the upper limit of the Safety Code 6 guidelines for 2.4 gigahertz. Calculating the approximate power density using the impedance and free space constant for far field exposure of 377 ohms, you get 3.4 watts per square meter. As the measurements were taken in the near field to approximate the spectacular peaks or spikes of radiation, multiply the value by 4 for an assumed 13.6 watts per square meter. Note, the multiplier of 4 does not take into account the possibility of other confounders such as stored energy, grounded, induced energy, which if present would increase the now 13.6 even more. According to Dr. Kane, cellular telephone Russian relate, 100 times the gain is possible. Even at 13.6 watts per square meter, this router may have exceeded the previous version of Safety Code 6 in 2009 and far exceeds the 5.5 watts per square meter in the 2015 version. If the unit were on Wi-Fi, presumably a wireless device would be present and levels of radiation present would be even higher. A classroom full of Wi-Fi enabled devices and several routers or access points. Assume a router or access point per 3 connected devices. The level could far exceed the levels demonstrated.